It began with a statement so bold that it shook the entire technology world.
No monthly
It will be
bills,
the biggest
satellite
product
coverage
of
that
all
finally
time.
works in rural America.
Elon Musk did not imply, did not speculate, and did not soften the message. He declared that every human on Earth will want this device. For a nation watching tech, prices rise, cellular bills climb, and devices become more fragile each year that claim hits like a shockwave. And yet, when the Tesla Pi phone officially appeared at $175, the shock turned into a question. Millions over 40 are now asking, has Apple finally met the product that can destroy its dominance? The context unfolded rapidly. According to engineering analyses published throughout October and November, the Pi phone was designed around a principle no American carrier ever dared to offer. Instead of tying users to monthly plans, Tesla eliminated them entirely through lifetime Starlink connectivity. No SIM cards, no carrier fees, no dead zones in rural America. And for the first time, a phone that communicates directly with satellites without any external dish or bulky hardware. The shift began with a single breakthrough, direct-to-device Starlink integration. This is not a headline claim, but a working system capable of delivering up to 100 megabits per second across 98% of the United States. In regions like rural Texas, where Apple's fifth-generation networks only reach 70% coverage, this becomes more than convenience. It becomes liberation for seniors who have endured unreliable networks for decades. The numbers are brutal. Over 10 years, an average American spends around $1,200 on cellular plans. With the Pi phone that cost becomes zero. No data caps, no subscription renewals, no hidden fees. Just permanent global connectivity authenticated through quantum-secure laser links. Even the setup process, often frustrating for older users on traditional iPhones, becomes 80% faster. But coverage is where this transformation becomes undeniable. Drive across open roads at freeway speed, and the signal remains stable because the Pi phone's internal phased array antenna dynamically adjusts its beam in real time. Independent simulations show a 40% lower call drop rate compared to iPhones. Travel through California's dense redwood forests, and the Pi phone maintains 95% connectivity where standard networks often collapse. Even indoors, a well-known pain point for Apple users. The advantage remains clear. Multi-orbit handoff keeps signal strength above the threshold required for uninterrupted calling inside high-rise buildings. Apple devices still suffer indoor dead zones, affecting roughly a quarter of urban residents. And underground, the gap becomes staggering. In New York's subway systems, where traditional phones lose all access, Tesla's low Earth orbit connections retain up to 75% reliability without relying on ground repeaters. For older Americans, this is not a technical detail. It is a quality of life revolution. A phone that refuses to drop a call means safety, peace of mind, and connection in moments when communication matters most. Add more than 500 television channels delivered through satellite multicasting with latency below 20 milliseconds, and you begin to understand why analysts believe 2 million Floridians alone may abandon cable subscriptions. All of this happens inside a phone, costing $175, powered by a 2-inch phased array antenna that uses less than 2 watts. When scaled globally, this model threatens to erase more than $50 billion in telecom fees each year, a shift that could cut Apple's market share in the United States by 20% within 2 years. The first question now becomes unavoidable. If Starlink connectivity alone can break the entire cellular industry, what happens when Tesla adds durability that Apple simply cannot match? The shock of lifetime connectivity would have been enough to redefine the market. Yet Tesla pushed the disruption further by attacking an even more painful weakness in modern smartphones' fragility. For more than a decade, Apple normalized cracked screens, expensive repairs, and yearly upgrades. But the Pi phone challenges that entire model with a display system engineered not just to resist damage, but to behave as if it refuses to break. The transformation begins with its modular cyberglass architecture. a design strategy rarely seen in consumer electronics. Instead of the traditional single slab display used in iPhones, Tesla separates the visual layer, the touch layer, and the outer protective glass into independent modules held together by magnetic locking. This design allows impact energy to disperse across the entire surface instead of funneling into one fracture point. In standardized fall simulations, this approach cuts catastrophic breakage probability from 80% to under 20%. For seniors, this means one thing: a drop no longer equals disaster. Real-world physical tests reinforce the claim. The nanoparticle-infused glass used in the Pi phone reaches 1.5 gigapascals in hardness, allowing it to survive 6.5-foot concrete drops with a 95% success rate. Under identical conditions, Apple's flagship devices average just 60%. That gap is not a marketing point. It is a statistical difference large enough to reshape how people choose and maintain their phones. But the most significant shift is cost. Instead of replacing an entire display for hundreds of dollars, users can swap a single damaged layer in about 5 minutes for a part costing around $20. Analysts estimate this alone could shift 15% of Apple's repair market to third-party shops nationwide, undermining a major revenue stream Apple built around sealed, non-modular designs. Beneath the outer glass lies an equally pivotal, breakthrough, high-mobility oxide semiconductor technology. This material pushes electron mobility to 50 square centimeters per volt second, enabling smoother 120 Hz performance while using 30% less power than Apple's OLED architecture. For older users, the benefits translate directly into everyday comfort: cooler temperatures, fluid scrolling, and roughly 2 additional hours of battery life per day. Brightness and color performance follow the same engineering discipline. With peak brightness hitting 2000 nits, seniors can read screens clearly, even under harsh midday sunlight. Color accuracy remains exceptionally stable, and eye strain decreases by more than a third during long reading sessions. Many over 40 will immediately feel this improvement during navigation messaging and video streaming. The durability extends beyond impact and brightness. Thermal resistance reaches 300 degrees Fahrenheit, far exceeding the warping thresholds of Apple's displays, which begin deforming at 175 degrees. For Americans living in high heat regions like Texas, Arizona, or Florida, this translates into drastically fewer screen failures during summer months. Tesla adds one more layer of resilience: an intelligent micro-coating that self-fills shallow scratches with roughly 80% efficiency. Everyday wear becomes nearly invisible, extending the device's lifespan without external protectors. The question now grows more compelling: if this display is strong enough for Earth's toughest conditions. Why did Tesla engineer it to survive even harsher environments? The moment experts examined the Pi phone's internal design, one revelation became impossible to ignore. This device was not engineered only for Americans on rural highways or seniors tired of cracked screens. It was built for environments far more hostile than anything on Earth. That is where the conversation shifts from consumer technology to planetary engineering, because the Pi phone carries features that align directly with what future settlers will need on Mars. At first glance, it seems almost exaggerated. Why would a $175 smartphone include radiation shielding modular repairs and satellite-first communication? But the deeper the engineering community looked, the clearer the pattern became. These are the exact systems required for survival in a place where there are no cell towers, no repair shops, and no margin for error. The same choices that help a senior in rural Texas stay connected during a storm are the choices that let a habitat resident on Mars stay alive in complete isolation. The first and most decisive factor is communication independence. Unlike Apple's devices, which depend on terrestrial towers and carrier infrastructure, the Pi phone connects directly to Starship-linked Starlink relays. This means a colony of 100 people can maintain data links from the Martian surface to orbit without building antennas or repeater stations. Latency Latency stabilizes around 20 minutes, which is consistent with NASA's long-range communications, but handled with smaller and more efficient equipment. Apple's architecture cannot operate in this environment at all. Then comes durability, far more than simple drop resistance. Radiation exposure on Mars is 20 to 30 times higher than Earth's, and the Pi phone's cyberglass display, paired with high-mobility oxide shielding, absorbs roughly 90% of high-energy cosmic particles. In simulation models, this extends the device's usable life to roughly 5 years. For comparison, iPhone screens begin noticeable degradation in as little as 2 years under ordinary Earth conditions. Next is the question of power. Mars receives weaker sunlight, and dust storms can block solar energy for weeks. The Pi phone was engineered with extreme power discipline in mind. High-mobility oxide circuits consume 40% less energy during low-light operation, a requirement for functioning in environments where charging opportunities are unpredictable. When paired with a small solar panel, the device can operate indefinitely on Mars, consuming just a few kilowatt-hours daily. Surprisingly, these off-world survival features produce immediate benefits for everyday Americans. Seniors in Florida dealing with hurricane outages, veterans living in remote areas, or low-income residents enduring unreliable infrastructure will feel these improvements long before any human steps onto Martian soil. A phone that can endure radiation, bursts, and dust storms can certainly survive a blackout in California or a heat wave in Arizona. And then comes modularity, the most underrated but most transformational choice Tesla made. A cracked module costing $20 to replace instead of a $500 sealed display is not only cheaper, but essential on a planet where spare parts must be repairable by hand. For Americans, this translates into self-sufficiency. For a Mars colony, it becomes the difference between communication and isolation. All of this raises a single striking question. If the Pi phone is already engineered to function on Mars, what does this reveal about Tesla's long-term plan for integrating everyday technology into interplanetary life? To understand why the Pi phone feels so radically different from every device that came before it, we must look at the ecosystem surrounding it. Apple built its empire on Earth-bound infrastructure. Tesla, in contrast, built the Pi phone inside an ecosystem designed to operate from Texas to Mars orbit without changing a single line of architecture. And that ecosystem begins with the tightest integration ever seen between a consumer device and a spaceflight network. The Pi phone communicates through SpaceX's laser-linked Starlink constellation, the same system used for maritime operations, disaster zones, military exercises, and Starship missions. Instead of relying on fragile ground-based towers, it taps into a network that expands every month as new satellites launch. This is why the device performs equally well in New York subways, rural highways, and high-rise apartments. The underlying communication layer does not care about terrain foliage or carrier contracts. It only cares about physics. For seniors and Americans living in underserved areas, this is not a luxury, but a dramatic leveling of access. Apple's ecosystem collapses the moment infrastructure breaks. Tesla's ecosystem remains connected as long as the sky is visible even partially. Analysts from technology journals have pointed out repeatedly that this is the first mainstream phone designed to operate independently of any national telecom grid. That shift alone pushes the United States closer to universal digital access, something carriers have promised for decades but never delivered. But the deeper implications go far beyond connectivity. With the Pi phone, Tesla has created the first consumer device that scales upward from Earth to space, rather than downward from high-end models to budget devices. The same communication hardware allowing seniors to make calls without a SIM card is the same hardware that allows a colonist to send data to a Starship relay. This dual-purpose design is intentional, it is cost-efficient, and it is strategically aligned with Musk's long-term settlement plans. Then comes the question of resilience. Electronics exposed to temperature swings, dust storms and radiation, require materials that do not exist in Apple's manufacturing pipeline. Tesla fused high-mobility oxide layers, nanoparticle glass, and modular impact-dispersing structures because these materials perform reliably in unpredictable environments. And once this resilience is built in everyday users on Earth, reap the benefits automatically. That is why veterans, seniors, and low-income Americans groups, most affected by costly repairs, stand to gain the most. There is also a fundamental difference in philosophy. Apple built a software ecosystem designed to lock users in. Tesla built a hardware ecosystem designed to keep users alive. One depends on annual upgrades. The other depends on reliability and longevity. And when a device is engineered for long-duration missions, it naturally outperforms devices engineered for yearly turnover. This brings us to the financial consequences. If the Pi phone can survive radiation heat pressure changes and multi-year operation, how long will it last under normal American use? Analysts estimate at least 5 to 7 years without major component failure. That single fact threatens Apple's entire revenue model based on frequent upgrades and expensive service packages. A phone that refuses to break is a phone that refuses to be replaced, and that could destabilize a 15-year-old industry structure. So the real question now is not whether the Pi phone will affect Apple's market share, but how quickly the collapse of the old model will accelerate once consumers realize they no longer have to replace their phones every couple of years. And yet, even this disruption is only part of the story. The Pi phone's impact becomes even more powerful when we examine the economic ripple effects across telecom repair markets and the global device supply chain. By the time economists finished reviewing the Pi phone's technical briefings, one conclusion grew unavoidable. This device is not merely a competitor to the iPhone. It is a direct threat to multiple trillion-dollar industries simultaneously. Telecom repair services, cable networks, and even global supply chains face disruption on a scale they have not experienced in decades. And for Americans over 40, the consequences will be felt in their monthly bills long before they feel it in their hands. The first domino to fall is the telecom industry. For more than 30 years, carriers built profits on recurring fees, data caps, and yearly price hikes. But Tesla's Starlink first architecture strips those mechanisms away entirely. Experts estimate that if just 10 million Americans adopt the Pi phone, nationwide telecom revenue could drop by $10 to $15 billion annually. The reason is simple. Lifetime connectivity means lifetime revenue loss for carriers. No upgrades, no overage charges, no premium data tiers. A system powered by satellites does not need cellular towers, retail stores, or roaming agreements. Next comes the cable television sector, another industry heavy with aging infrastructure and costly monthly plans. With more than 500 channels delivered seamlessly through satellite multicasting, the Pi phone essentially turns every user into their own micro-broadcast hub. States like Florida, where average cable bills reach $150 per month, could see over 2 million households shift away from traditional providers. Cable companies have warned for years about cord cutting, but none of them imagined a scenario where the cutting would be done by a smartphone costing $175. Repair markets face an equally sharp blow. Apple built a tightly controlled ecosystem with sealed screens, specialized tools, and authorized service centers. The Pi phone's modular display architecture bypasses all of that. A user can replace a cracked layer at home for about $20. Multiply that by tens of millions of Americans, and analysts project a 15% decline in Apple's repair revenue within the first 2 years. Independent repair shops, meanwhile, may flourish under Tesla's design philosophy, which encourages swapping components rather than replacing full assemblies. Even the global supply chain feels the shock. Traditional smartphones rely on complex, geographically distributed networks, vulnerable to political tensions, shortages, and shipping delays. Tesla's simplified module-based components reduce dependence on high-risk regions and accelerate manufacturing timelines. That means fewer bottlenecks, shorter lead times, and a supply chain less affected by geopolitical instability. For seniors, this means stable pricing and availability rather than unpredictable seasonal fluctuations. But perhaps the most dramatic consequence is psychological. For decades, Americans accepted fragility as normal. They tolerated rising fees, shrinking battery life, expensive repairs, and planned obsolescence disguised as innovation. The Pi phone breaks that conditioning. When a device gives you lifetime connectivity, near indestructible materials, and multi-year durability, it forces a reevaluation of what technology should have been providing all along. This shift reaches far beyond personal convenience. It alters consumer expectations across every tech sector. If a $175 phone can offer global satellite calling, why should laptops, tablets, and even home internet systems continue operating under outdated, overpriced models? The economic ripple becomes profound. The Pi phone does not simply compete. It exposes the inefficiency of the old system. And when consumers realize that a future without monthly bills, fragile screens, and forced upgrades is possible, demand for traditional devices collapses rapidly. But there is still one final question that ties everything together. What does the Pi phone ultimately prove about Tesla's strategy, and why does this moment mark a point of no return for Apple and the global tech industry? By the time all 6 pillars of the Pi phone's engineering are placed side by side, lifetime Starlink connectivity, modular fiberglass durability, radiation-resistant materials, oxide-based power efficiency, Starship-linked communication systems, and a repair model that cuts costs by over 90%. A single truth emerges with unforgiving clarity. This device is not an upgrade. It is a full system reset. For more than 15 years, consumers lived inside an ecosystem shaped by Apple's rules. Screens cracked easily. Batteries faded quickly. Monthly carrier fees climbed without warning. Repairs cost hundreds. Rural and underground areas remained dead zones. And each year, customers were told the same message: you need a new phone. Older Americans felt this pressure the most, often paying more for connectivity and repairs than for the device itself. The Pi phone breaks that cycle entirely. The combination of Starlink-powered independence and physical resilience represents a philosophical shift in how technology should serve people. Musk's device does not punish mistakes. It does not penalize age, location, mobility limitations, or income level. Instead, it delivers stability, longevity, and universal access qualities long abandoned by traditional tech models. For seniors, the advantages are immediate and tangible. A phone that never drops calls means safety during emergencies. A display that refuses to crack means no unexpected repair bills. A battery that lasts longer and operates efficiently in low-light conditions supports medication schedules, health apps, and daily routines. And lifetime connectivity eliminates the stress of rising monthly costs, a burden especially heavy for Americans on fixed incomes. The broader market implications stretch even further. Telecom carriers repair monopolies, and cable networks depended on consumer vulnerability. Tesla's ecosystem eliminates that vulnerability by design. When infrastructure fails, the Pi phone's satellite first system remains online. When temperatures rise, the oxide layers stay stable. When drops occur, the modular glass absorbs the impact. And when future missions expand beyond Earth, the communication system is already compatible. The result is a device engineered with a depth of foresight that Apple's annual iteration model cannot compete with. For the first time, a mainstream smartphone reflects future planetary demands rather than short-term profit cycles. And that difference, the willingness to design beyond Earth's limitations, exposes the boundaries of every other manufacturer, still depending on fragile hardware and expensive ecosystem lock-ins. This moment marks a historical turning point. Apple's reign was built on convenience, design, and prestige. Tesla's entry is built on physics, resilience, and survival. The company that wins the next decade will be the one whose devices extend human capability, not restrict it. And the Pi phone demonstrates that those capabilities no longer require premium pricing or yearly replacements. They require engineering vision, something Tesla injected into every layer of this device. The revolution is no longer theoretical. It is already happening in real time. The Pi phone shows that connectivity should be free, durability should be standard, repairs should be simple, and a device should last years, not months. Once consumers experience this level of reliability, there is no return to the old world of fragile phones and endless subscriptions. Tesla didn't just challenge Apple. It exposed the flaws the industry hoped no one would question. And now that the blueprint for a better system exists, the market cannot go back. If this breakdown changed the way you see the smartphone industry now, is the moment to stay ahead of what comes next. The Pi phone is not just another tech release. It is the beginning of the most dramatic market shift in modern consumer history. A $175 device offering lifetime connectivity, near indestructible materials, satellite-first communication, and modular repairs is not an incremental improvement. It is a challenge to everything Americans were told to accept. For years, telecom providers convinced millions that rising fees were normal. Apple trained consumers to tolerate fragile devices and costly service plans. Cable companies built entire empires on monthly billing cycles. But the Pi phone shatters that system and shows people over 40 seniors, veterans, and everyday families the technology can be fair, durable, and affordable without compromise. So here's the question. Only you can answer if the future is already changing. Will you watch from the sidelines or be part of the first wave that understands the new rules? Your engagement is what drives deeper analysis, exposes industry truths, and keeps this channel independent of corporate influence. If you want ongoing coverage of the Pi phone launch, Starlink's expansion, SpaceX's engineering breakthroughs, or the market consequences Apple doesn't want consumers to notice now, is the time to support the channel. Hit like if you believe the old tech system needed to change. Comment. Your thoughts is lifetime connectivity, the feature that changes everything. Share this video with someone who still thinks monthly phone bills are unavoidable. And most importantly, subscribe so you never miss the updates that others overlook. The revolution has already begun. Do not get left behind paying for the old world.